everybody, welcome to another video. Today we're going to learn how to solve equations with variables on both sides. Now real quick, before we start, it is really important that you watch our previous video on equation solving so that you can properly follow along. So now let's get started. Here we have an example that I've set up. Now the idea when solving an equation with variables on both sides is that you want to isolate the variable on one side. But before you can go ahead and do that, there are multiple steps. First, you have to distribute and then combine like terms. Well, in this case, we have nothing to distribute, so we would just jump right into combining like terms. And as you can see right here, we can combine this negative 7x and this negative 3x, and we will get negative 10x plus 2 equals negative 8x minus 8, since there's nothing left to combine in this side right here. So now, this is when you would move the variable to one side, so that then you can solve for, in this case it's x. So you could do it either way, but in this case I'm just going to go ahead and add 10x to both sides. Plus 10x to both sides, and you get 2 equals 2x minus 8. Now, think about it. We want to isolate the variable, so we're going to add 8 to both sides to have x by itself on one side, and we get 10 equals 2x. We would divide both sides by 2 to cancel this coefficient out, and we would get that x is equal to 5, since 10 divided by 2 is 5. Okay, here we have another example. And as I mentioned before, the first step would be to distribute. And in this case, we do have something to distribute. As you can see, there's a parentheses right here. So we would distribute the 4 inside the parentheses. So we would get negative 8n plus 4, since 4 times 1 is 4, plus 20n, since 4 times 5n is 20n, equals negative 6n minus 14. Now, notice that we can combine like terms on this side of the equation, and that is by adding negative 8n to 20n, and we will get 12n plus 4 equals negative 6n minus 14. And once again, I'm going to move the variable to one side, so that could be, I could do plus 6n on this side, which is what I'm going to do, or I could also do minus 12n, it doesn't matter, but I'm just going to go with plus 6n. You'd get 18n plus 4 equals negative 14. Now we would subtract 4 from both sides to get 18n equals negative 18. Divide both sides by 18. These would cancel out, so we will be left with n is equal to negative 1. And that is how you would apply the distributive property to solve an equation with variables on both sides. So now let's apply our knowledge to this word problem over here. So what it's telling us is that Lenny makes $55,000 a year and gets a $2,500 raise every year she works. Now, Nablo, on the other hand, makes $62,000 a year and gets a $2,000 raise every year he works. Now, we are asked to find, after how many years, if they will earn the same amount of money. So let's come up with some expressions to represent how much they make. So first of all, let's zoom out a little. Let's define a variable. So let's let so we're gonna let t equal the number of years they work. So now, and we're also gonna let c equal the amount of money amount of money they make. So let's come up with an expression for Lenny. So the amount of money Lenny makes, so C, is going to be $55,000. So that's the set amount, plus this two $2,500 raise he gets every year she works. So 25,000 T, because it changes after every year she works. Now, let's come up with one for Nablo. You will see this is pretty similar. So C is going to equal $62,000, which is a fixed amount, plus the raise he gets every year he works. So 2,000 T, since it adds up every year. Now, you may be wondering how we're going to use these two to find out after how many years they're going to earn the same amount of money. Now, you would just make the equations equal. So $55,000 plus 2,500 T is equal to $62,000 plus 2,000 T. And now you might notice that this is an equation with variables on two sides. So now we're just going to use what we learned to solve this. So since there's no like terms to combine, I'm going to move the variable to the left side. So minus 2,000 T minus 2,000 T. So minus 2,000 T on both sides. And we would be left with 55,000 plus 500 T is equal to 62,000, since these two cancel out right here. Now, we have another step before we can actually solve for T, which would be subtracting 55,000 from both sides to isolate the variable. So minus 55,000 from both sides, these would cancel out. So in this side, we will be left with 500 T is equal to, then that will be 7,000. Now, we're just going to divide both sides by 500 to cancel this coefficient out, and we will be left with T is equal to, well, let's do this real quick, 7,000 divided by 500, so it goes in one time, we're left with 2, bring the 0 down, it goes in 14 times, so T is going to equal 14, but remember, we are trying to find out after how many years Lenny will earn the same amount of money as Nablo. And we let C, we defined it up here, let the number of years they work. So therefore, Nablo will earn the same amount of money. Nablo and Lenny will earn the same amount of money after 14 years. Thank you so much for watching. Don't forget to drop a like, comment if you have any questions, subscribe, and see you next week.